Have you ever wondered how batch operating systems work? It's a question that might have crossed your mind as you navigate the complex world of information technology. A batch operating system, in its simplest form, is a system that accepts jobs or tasks in groups or batches without any interference from the user. It's like a chef preparing a set menu, cooking each course in sequence rather than catering to individual orders. This concept, while not new, is still very much in play in today's tech landscape. The batch operating system remains a crucial component in many industries, from banking to manufacturing, and even in scientific research. It's the silent workhorse, handling tasks efficiently and systematically, while we carry on with our lives, oblivious to the heavy lifting happening behind the scenes. Intrigued yet? Let's delve into the fascinating world of batch operating systems. Batch operating systems didn't just appear out of nowhere. The birth of batch operating systems was born from a need to make computing more efficient and less labor-intensive. Let's take a trip back in time, all the way to the early days of computing. In the mid-20th century, computers were enormous, room-sized machines. They were expensive and in very high demand, yet they were operated manually. This meant that a computer operator had to physically load a program, then data, wait for the computation to finish, and finally unload the results. This was a time-consuming process, and the computer often sat idle waiting for the next task. The concept of a batch operating system was introduced to address these inefficiencies. The idea was simple: group a batch of similar jobs together and run them as a unit, without any manual intervention. This process, known as batch processing, drastically reduced the idle time of computers and made them more productive. The first batch operating system was introduced by IBM in the late 1950s. It was called the IBM 704 and was a game changer. The IBM 704 used a magnetic tape to store and read data, which was a significant technological advancement. This system marked the beginning of a new era in computing, where machines could work independently without constant human intervention. Batch operating systems continued to evolve over the years. In the 1960s, the introduction of spooling, a process where data is temporarily held and then used when needed, further improved the efficiency of these systems. The 1970s and 1980s saw the development of more advanced batch operating systems, capable of handling complex tasks and managing larger volumes of data. Fast forward to today, batch operating systems are still very much part of our digital world. They have adapted to the changing technological landscape, integrating with modern technologies such as cloud computing and big data analytics. Now that we know where batch operating systems come from, let's explore where they're used in the real world. You might be surprised where batch operating systems show up in our everyday lives. They are integral to many industries, silently streamlining operations, enhancing efficiency, and boosting productivity. You may not see them, but they are there, working in the background, making our lives easier. Let's start with banking. Ever wondered how banks manage to process thousands of transactions every day? Batch operating systems are the heroes behind the scene. They gather transactions throughout the day, and then, during off-peak hours, they process these transactions all at once. This way, they reduce the load on the system and ensure smooth operations. Next, let's talk about healthcare. Hospitals are places of constant hustle and bustle. Behind this hustle, batch operating systems work tirelessly to keep everything in check. Whether it's scheduling patient appointments, managing medical records, or processing lab results, these systems handle large volumes of data effectively and efficiently. Manufacturing is another industry where batch operating systems shine. In factories, these systems control and monitor production processes. They gather data from various sources, analyze it, and then make decisions based on that analysis. This could range from adjusting the speed of an assembly line, controlling the temperature of a furnace, or even initiating safety protocols when necessary. Even in the realm of entertainment, batch operating systems play a crucial role. Consider how streaming platforms handle millions of requests every day. They use these systems to batch process requests, ensuring that your favorite shows and movies are always just a click away. So, whether it's handling your bank transactions, managing your health records, controlling the production of your favorite products, or even streaming your favorite shows, batch operating systems are there, working behind the scenes. They are unseen, but their impact is undeniable. Batch operating systems are everywhere, silently making our lives easier. But how exactly do they work? You're probably asking, how do these batch operating systems actually work? Well, let's dive in and get a good understanding, shall we? Batch operating systems work like a well-oiled machine, diligently processing tasks without needing any user interaction. Picture a busy post office. The workers, or in our case the operating system, sort through packages or jobs that are brought in. These jobs are then put into a batch, similar to how mail is sorted into different bins based on their destination. This is known as job scheduling. The operating system decides the order in which tasks are processed based on certain criteria, such as the size of the job or its priority level. It's like the post office deciding which mail to deliver first, the one-day shipping packages or the standard delivery ones. Once the jobs are batched together, the operating system then processes these tasks one after another without any breaks in between. It's an efficient system, like an assembly line, where tasks are completed in a streamlined manner. But what happens when there are no more jobs to process? Does the operating system just sit idle, twiddling its virtual thumbs? Not at all. The batch operating system is smart. It uses this idle time to prepare for the next batch of jobs, arranging them in the most efficient order for processing. It's like the post office sorting the mail for the next day during their downtime. This process of job scheduling and processing tasks is repeated continuously, ensuring that the operating system is always working, always processing, and always ready for the next batch of jobs. It's a system designed for efficiency and speed, keeping the workflow smooth and uninterrupted. So that's the magic of batch operating systems. But what makes them so effective and efficient? Like all things, batch operating systems have their strengths and weaknesses. Let's dive into the advantages first. Batch operating systems are like the unsung heroes of the digital era. They work tirelessly in the background, orchestrating tasks with precision and efficiency. One of the primary advantages of these systems is the reduction of manual labor. They can be programmed to execute tasks automatically, allowing for a hands-off approach. This automation can run during off-peak hours, ensuring resources are utilized optimally. Batch operating systems are also masters of multitasking. They can handle multiple jobs sequentially without human intervention. This increases productivity as it allows for continuous operation. From processing large volumes of data to executing complex calculations, these systems can tackle it all without breaking a sweat. Moreover, batch operating systems are cost-effective. They reduce the need for dedicated manpower and are less prone to human error, leading to a reduction in operational costs. They also make efficient use of system resources, reducing waste and further contributing to cost savings. However, every coin has two sides. The flip side of batch operating systems is their limitations. One significant drawback is the lack of user interaction during processing. Unlike interactive systems where users can modify tasks on the fly, batch systems do not provide this flexibility. Once a job starts, it cannot be altered until it's complete. Furthermore, batch systems operate on a first-come, first-served basis. If a small job is queued behind a large one, it must wait its turn, even if it's urgent. This could lead to inefficiencies and delays. Lastly, error handling can be a challenge. If a job fails, it can disrupt the entire batch. Identifying and rectifying the issue can be time-consuming and may require a manual intervention, negating some of the benefits of automation. So, batch operating systems have their pros and cons, but they continue to be a vital part of our digital world. Despite their limitations, they remain a crucial tool in myriad industries, from finance to healthcare, and continue to shape our digital landscape. We've journeyed through the world of batch operating systems, but the conversation doesn't have to end here. We've touched on the intrigue, the birth, and real-world uses of these systems. We've delved into their understanding, discussing their advantages and limitations. But there's so much more to learn, to discover. The world of batch operating systems is vast and ever-evolving, a testament to the dynamism of technology. In this era of fast-paced development and endless curiosity, we encourage you to dive deeper, explore, continue learning. The more you know, the better equipped you'll be to navigate the technological landscape. This journey doesn't end with us. It continues with you, your curiosity, your desire to understand. And remember, learning is an ongoing process, a never-ending journey. Thank you for joining us on this exploration of batch operating systems. If you've enjoyed this video, don't forget to like, share, and subscribe. And we'd love to hear your thoughts in the comments below. Until next time, stay curious and keep exploring.